All right, so today we're moving on to component 3, which is exponential functions. So we are talking about exponential functions, and they're defined by the parent function of f of x equals a times b to the x. So this is just the parent function. Of course, we can have transformations. They might move left or right, up or down, and there might be reflections, but this is just the parent graph, where a represents the initial amount and b represents the growth or decay. So when we're talking about an exponential graph, it's going to look like this. So because it's going left forever and right forever, the domain is all real numbers, or negative infinity to positive infinity. The range, however, there is a asymptote, which is at 0 unless it's shifted up or down. So our range would be that y has to be greater than 0, not or equal to, right? Because at 0 there's an asymptote. Now for the intercept, the y-intercept is going to be at a. So the intercept is 0a. The equation of the asymptote is y equals 0, unless, of course, shifted up or down, except, of course, if it's moved. Exponential growth is when the factor b is greater than 1. Okay, so a number greater than 1. And exponential decay is when b is between 0 and 1, meaning it's a fraction between 0 and 1. That would mean it's decaying. This is a growth because it's getting higher as we go to the right? It's growing, so this would have a b value of more than 1. And exponential decay would go this way. It's getting really, really close to 0 as it goes to the right, instead of getting really big as it goes to the right. Okay, the number e is defined as an expression this as n goes to infinity. So if I make n bigger and bigger and bigger and bigger, we get closer and closer to this number e, which is, if we plug e in our calculators, it's right above the division sign. E is approximately 2.718281828 dot 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 dot. It goes on and on and on and on forever. Just like pi. Pi and e are very similar. They're a number represented by a letter. Okay, so even though this is not in number form, e just represents this number. So the first thing we're going to do is graph. So we're going to start with a very basic function. So we've got f of x equals 2 to the x power. Okay, so we're going to create a xy chart to graph this. Our x values are going to be -2, -1, 0, 1, 2. Okay, and then the y values are coming from the base. So because the base is 2x, we're going to make the y values based on 2 to the x. So 2 to the -2, remember if you have a negative exponent, it means go to the bottom. So that would be 1 over 2 squared, which would be 1 over 4. -1, a negative exponent says the 2 goes to the bottom, so 1 over 2 to the first power would just be 1 over 2. Remember, anything to the 0 power is 1. 2 to the 1 would be 2. 2 to the second power is 4. Now, there's nothing else happening here, right? We don't have any addition or subtraction happening to the x's. We don't have any addition and subtraction happening out here. We also don't have any transformations in the front. So there are no transformations happening in this. Okay, this is technically 1 times 2 to the x. So a is 1 and b is 2. Okay, so that means that we can graph these. We've got 0, 1, 1, 2, 2, 4, negative 1 1/2, negative 2 1/4. So our graph looks like this, with our horizontal asymptote being at y equals 0. So our horizontal asymptote is at y equals 0. The domain is all real numbers, and the range is that y has to be greater than 0. Okay, so this is very basic. No transformations are happening here, so very basic graph. Okay, however, on the next problem, we've got a couple transformations here. So we're going to make our XY chart. We're still going to do -2, -1, 0, 1, 2. But this time, our base is 3 to the x. So we're going to make our chart based on 3 to the x this time. So 3 to the -2nd power would be 1/9. 3 to the -1 would be 1/3. 3 to the 0, 1. 3 to the 1, 3. 3 to the 2nd power, 9. Okay, so this is our very basic table. Now, if we look, we've got two transformations here. We've got this 2 in the front, and we've got this +1 with the x. So if you think back to transformations last year, the transformations we did this year, remember when something is with the x, that means it's moving left or right. And remember, anything with the x is opposite. So because it's +1, our transformation is that it's moving left 1, which means I have to subtract 1 to all of the x's. So the x's become -3, -2, -1, 0, 1. Okay, we also have this 2 in the very front, which means it's a vertical expansion of 2, right? It's being expanded vertically by 2. So that means to all of the y's, I'm going to multiply by 2. So this becomes 2/9, 2/3, 2, 6, and 18. So now when we graph, we're at -3, 2/9, -2, 2/3, -1, 2, 0, 6, and then 1 is all the way up here at 18, which we can't really graph, right? Now, there was no vertical shifts, right? So this horizontal is only going to be moved if we're moving vertically. We got it shifted to the left 1, but it didn't get shifted up or down. So the horizontal asymptote is still at y equals 0. The domain is still all real numbers, and the range is still y is greater than 0. Connect our graph here, and there is our graph. Okay, let's look at number 3. So in number 3, we're going to start with our XY chart. This time, our base is 4 to the x. So 4 to the -2nd power would be 1/16, 1/4, 1, 4, and 16. Now the transformations we have here, we've got a -2 with the x, which means the transformation would be right 2. So we always think opposite, so I'm going to be adding 2 to all of the x's. And then we also have a -1 on the end, which means it's going down 1. So we're subtracting 1 to all of our y's. Okay, so if I'm subtracting 1 from 1/16, that's going to give me -15/16, -3/4. So here is our new ordered pairs. So we're at 0, -15/16, so almost -1, 1, -3/4, 2, 0, 3, 3, and 4 way up here at 15. Now, because it got shifted down 1, usually we have a horizontal at y equals 0, but that horizontal also got shifted down 1, so now the horizontal is at y equals -1. So at y equals -1, We're going to have our horizontal, and then we're going to fill in our graph here. Domain is still all real numbers. Now this time the range is that y is greater than -1 because it got shifted down. So now it's greater than everything above -1. Okay. So -2, -1, 0, 1, 2. Now because it's a 1/2, when I raise a 1/2 to the -2, that means that 1/2 is going to flip and we're actually going to get 4. 1/2 to the -1 would be 2. 1/2 to 0 is 1. 1/2 to 1, 1/2 to the second. So as you can see, instead of getting bigger, like in our other problems, it's getting smaller. So this is a decay problem because this 1/2 is going to make it go down. It's decaying. Okay, now our transformations, we've got a multiply by -2 here. So we're going to have to multiply all of our y's by -2, which means there's a vertical expansion by 2. It also means that this negative means there's a reflection over the x-axis. Okay, we also have this +7 on the outside, which tells us it's moving up 7. So we're also going to have to add 7. So we'll go ahead and change, multiply by -2. And then add 7. That would be 6.5. So -2, -1, -1, 3, 0, 5, 1, 6, 2, 6.5. Okay, so because it got shifted up 7, instead of being at 0, it got shifted up to 7. So our horizontal asymptote is at y = 7. So our graph looks like this. The domain is still all real numbers. It's still going left forever and right forever. This time, because it's below the 7, y is less than 7 because it's below our horizontal asymptote. Okay, I'm going to leave number 5 for you to try on your own. Keep in mind with number 5, this is like saying -4 to the x plus 1. These are the same thing. So make sure you pay attention to what your transformations are here. Okay, so on number 6, we've got an E graph. Okay, so if we have E, if I go to make my chart, are you guys going to know what e to the second power is? Probably not, right? So the chart isn't going to really help us with e's, so you don't have to do a chart with e. I am still going to ask you to fill in all of this. Okay, so our transformations, we have a negative in the front, so that's a reflection over x-axis. We have a -3 with the x, which means it's moving to the right 3. Now our horizontal asymptote is typically at y = 0 unless it's getting shifted up or down. This does not say it was shifted up or down, so it's remaining at y = 0. Okay, the domain is always all real numbers. So our range is either going to be y is greater than 0 or it's going to be y is less than 0. Well, if it's reflected over the x-axis, typically it would be over here, right? But if it's reflected, now it's going to be down here, so now it's going to be less than 0. Okay, now to get our graph here, we're just going to use our calculator and find some points. So we're going to go to y equals, and we're going to plug in our graph. So negative e to the x minus 3. We're going to go to our table of values here, and we're going to pick up some values. So we've got -3, -1. That seems like an easy one to graph. Okay, Okay, -4, -2.7, so a little bit over, almost -3. Oh wait, what am I doing? This isn't negative, it's 3 -1. Sorry guys, 3 -1, 4, there we go, 5 -7, 7, a little bit over -7. Okay, let's also do at 0. 0 was negative, so it's really, really close to 0. So here is our graph. And there we go. So with these ones, I'm not going to expect that you show a table, but you will still be expected to do this and to use your calculator to graph it. Okay, I'm going to leave you guys to try number 7 and then check your answers. All right, so the next two things we're going to talk about, these last two problems in this video, is we're going to do exponential regression. So we want to determine the exponential function of this graph. So we've got a bunch of different ordered pairs here. So I'm going to make this into an XY table. So -1 was 1 over 6, 0 was at 1, 1 was 6, and 2 was 36. Now we might be able to figure out what this graph is without using our calculators, but I'm going to use our calculators. So we're going to go to the Stat button, which is right here underneath Delete. We're going to edit. If you need to clear your list, go ahead and go up and press the clear button. Do not press delete. Press clear and then enter. That'll clear everything out. So under L1, we're going to put our x values. So -1, 0, 1, 2. And under L2, we're going to put our y values. So 1 divided by 6, 1, 6, and 36. Now this is an exponential graph. So now we're going to go back to Stat and go to Calculate, and we're going to find exponential reg right here under 0, exponential reg. L1 is our x's, L2 is our y's. We don't really need to store it anywhere. Calculate, okay, so it tells us our equation is y equals a, and a is 1 in this case, times b, which is 6, to the x power. Okay, so let's do number 2. So our x's. Okay, now let's go to our table. So Stat, edit. Our x's didn't change, just our y. So -1/8, -1, -8, -64. Now when I go to Stat, Calculate, exponential reg, oh no, it tells me that I can't do that. Well, here's the thing. Our calculator doesn't know how to handle these negative symbols. Okay, so when we plug it into our calculators, I'm going to go back and I'm going to delete in my Stat, edit. I'm going to delete all of the negatives. So I'm just going to make it 1/8, 1, 8, and 64. However, if I get rid of the negatives, the only way that these are going to be negative is if I make a negative in the front, right? Because there's a reflection. So now when I go to Stat, Calculate, now it'll tell me the answer, but I just have to know that I have to make that a -1 times 8 to the x.